Hello everyone, my name is Audrey Vega and this video is for my Computer Networking 102 class, and today I will be doing the Cisco Packet Tracer Activity File 8.2.2.7, and that is configuring an OSPF version 2 in a single area. So let's get started. Okay. A little bit of background about OSPF version 2 is that it is a link state routing protocol for IP version 4. OSPF was designed as an alternative routing protocol to RIP, and it is this day in the industry the most commonly used routing protocol out there. So wherever I've been told, wherever you go, OSPF routing is generally what you will be approached with. All right. And this particular packet tracer, what I'm responsible for doing is configuring the 3 routers with basic single area OSPF version 2, and then verifying the connectivity between the end devices. And in this particular packet tracer, the IP addressing is already configured, so that makes it a little bit easier. All right, and so the first step that we need to do is we need to configure the OSPF on all the routers. And so we're going to start with router 1. Move that, make it a little bit bigger. And we want to enter the global configuration mode in the router. And to enable the OSPF version 2, we use the command router OSPF, and the instructions require that I use the process ID 10 for this command, so I'll just add 10. The process ID value represents a number between 1 and 65,535, and this number here, this is the number I'm talking about, is selected by the network administrator. Usually this process ID value is locally significant, which means it does not have to be the same value on the other OSPF routers to establish adjacencies to those neighbors, but we won't worry about that right now because our instructions strictly say to use the ID 10. So that's what we're going to do. And so we have now enabled the router, the OSPF version 2 on this router, and we need to give this router 1 an ID number. And in our instructions, router 1 is given the router ID of 1.1.1.1. And what we want to do now is we want to configure the networks that are directly connected. So we have this connection right here, this connection right here, and this one right here. So we want to add those networks. So we do that by entering network 172.16.1.0. with the subnet being 0.0.0.255, area 0. Okay, and the area right here, this area right here, the excuse me. What we're doing now is we're configuring interfaces that partake in this particular OSPF area. Any interface on a router that matches the network address in the network command are enabled to send and receive OSPF packets. As a result, the network address for the interface is included in the OSPF routing updates. And so the basic command for getting these interfaces is network, and you want to enter the network address, which what we did here, and you want to add the wildcard mask area and then the area ID. And so that's there for one. Then we have a couple more to do. Network 172.16.3.0 0.0.0.3, and then area 0, and then network 192.168.10.4, and 0.0.0.3, area 0. Okay. Now a little bit about what's this area here is this is called the wildcard mask, and it's in order to enable OSPF interfaces, you need to use the wildcard mask because OSPF is classless by design. So therefore, the wildcard mask is always required. The wildcard mask itself is a string of 32 binary digits used by the router to determine which bits of the address to examine for a match. And they have this whole cool way of doing this. So we have assigned these three interfaces to router 1. And what we want to do is now we want to set up a passive interface for the gigabit 0-0. So let's go passive. Interface gigabit 0/0. Okay, and we want to save this configuration. So we want to say do copy run start. All right, and that's so what we've done here so far is we've enabled the OSPF configuration on router 1 and given the router 1 ID of 1.1.1, and we established these three interfaces on that router. And we have just saved our configuration, and we will be going to router 2 and doing the same. Okay, just make this a little bigger. All right, we need to go into the global configuration mode, and we want to enable OSPF with the process ID of 10. And router 2 has the ID number 2.2.2.2. And now we want to assign interfaces to this router, and those interfaces we can find are the ones that are directly connected to the router, which would be this one, and this one. So we set up these interfaces with the network command. 172.16.2.0 0.0.0.255 area 0. Next we have network 172.16.3.0 with the 0.0.0.3 area 0. Oops. Just press enter there, and one more. Network 192.168. Dot 10, sorry, dot 8. Well, we'll just do this. Okay, so network, oops, 192.168.10.8 0.0.0.3 area 0. Darn it. Okay, and just like in router 1, we want to set up a passive interface for that gigabit 0 /0 interface. So we want to make that passive. So we just issue the passive interface command for the G0/0. And we want to save this configuration with the do copy run start. All right, that configuration is finished for router 2, and we'll go to router 3 and we'll do the same. All right, entering the global configuration mode. And we're enabling the OSPF process ID 10. And router 3, like router 2 and 1, has a very easy router ID of 3.3.3.3. And now we want to establish the interfaces for router 3, which are these interfaces right here. The 192.68.10.4, this one here, the .10.8, and the .1.0. So we'll just add those in there. 192.168.1.0 0.0.0.255 area 0. And the next one, network dot 4.0. Oops, wrong. That's .10.4. 0.0.0.3 area 0. Network 192.168.10.8 0.0.0.3 area 0. Whoops. What did I do? Oh, I see. All right. And what this little message is telling us is that the router, the OSPF configuration, it goes in different states, and what it's telling me now is that it's currently loading to full, which means that it is now able to receive any packets from all the other routers on the OSPF protocol. So now what we want to do is we want to save our configuration. do copy run start, and that's saved. Oop. All right, and next step in this packet tracer, what we need to do is we need to verify OSPF routing is operational on each and every router. So, so we're going to go into router 1. We're going to go into regular mode, and to see if the OSPF routing is operational, we issue the command show IP route. I'll stretch this out a little. All right, and what we're looking at right here is this information right here. What this is telling us is that I'm not exactly sure right at this moment, but this shows that the OSPF is operational in router 1. So we'll go down to router 2, and we'll do the same there. Show IP route. Okay. And it's saying that it is good to go. And we'll do the same on router 3. So now we have verified that the OSPF routing is operational on each router. Now, what we have to do is verify the configurations that we just made. And right now, what we should be able to achieve is that each PC should be able to ping the other 2 PCs. So we'll just try. Okay, that one failed. That one failed. And that last one was successful. So I think what happened was it took a minute for the configuration to take effect. So we'll just try we'll just try to ping again. Successful. Successful. All right, they were all successful. So that means that our configuration was correct. All right, and we'll go over here, and it says that we don't have a 100% completion. So I'm not quite sure what we did wrong. And so to figure that out, we'll just go to check results. And we missed it right here. We didn't set up the passive interface on router 3. So what we'll do is we'll go back and we will fix that. Okay. So we'll go into here. Need to get into that global configuration mode. Oops, it already is there. So not exactly sure a short way of doing this, so I'm just going to redo the whole process again, just really fast. Or I can just go and enter that command and issue the passive interface gigabit 0/0. Now we'll save that configuration and we'll see if that helped. Yep, we have a 100 completion rate. See, we fixed our passive interface on that gigabit 0/0 interface port. Okay, and that completes this packet tracer and everything that I was supposed to be doing in it. So I will see you next video. Thank you.